Okay, can you see my screen as well?
Yes, sir.
Okay. Okay, so I think we can start. Welcome everybody to this lecture series. I conducted the same kind of series last year and year before that also. So I have some idea about how we should proceed to conduct these sessions. But as you can imagine, every year is a bit different. This time, what I want to do to begin with is go over the exam paper that all of you already solved last Sunday. And basically, even before I try to start teaching new topics, I feel that we should spend some time to consolidate what we already know. And that is an important aspect which will be helpful for us for any exam. So, if you ask me, the paper was designed based on theory which all of you already know well. The difficulty, I think, is that you are looking at the theory as properties or theorems, but what I want you to do first is reorient your mind to start thinking of them as problem solving tools or techniques. So how can you approach every theorem or every property, and how can you make it useful to solve any actual problems? So that is what you need to learn. And one important way to start doing that is actually constructing new problems. Okay. So this is going to be one focus area which I'll always urge you to come back to, that whenever you get a chance to try any problem, uh, after you solve the problem, you have to do a couple of things. First is you need to spend some time to understand what is the motivation behind that problem. So basically, maybe I'll just. So actually, these are some points which I had gone through in one of my training camps, and they are relevant for us also. That's why I'm showing them on the screen. So what you should do while solving problems is firstly focus on quality or quantity. By that, what I mean is that if somebody solves 10 times more problems than you, that doesn't necessarily mean that they are 10 times better. What matters is for every problem you are solving, what are you doing with afterwards? Are you just moving on to the next problem, or you take the time to find alternate solutions, multiple solutions? And more importantly, are you able to find a motivation for the solution? I mean, somebody can come and give you the solution. Even I can right now solve all the 15 questions in front of you, but that is not that useful to you. What should be useful to you is how you should discover this solution. What is the hint that you should look for, by which your attention will get directed towards one particular line of thought. Okay, so that motivation behind every solution is a very important concept. That what did you learn from every problem? And another important thing which I always keep saying, and unfortunately not all students follow this, is the importance of revision, because you will solve many problems over the coming months. But if you don't remember what you did, then you will sort of lose your accumulated knowledge. So it's important to revise and important to build tools which will help your revision. So one of the things you have to do is create your own sort of memory toolkit. So all the important techniques that you learn, problem solving techniques that you come across, try to document them separately. And the more short and succinct your summary is, the easier it is for you to revise it again. See, if your summary is as long as the original text, then it will take the same amount of time for you to revise. But if you are clever and smartly organize your summary in such a way that in minimum number of pages you are covering maximum content, then that's a very useful revision tool that you have. Okay, and then that will motivate you to do the revision more often. So this is something that you should always try to aim towards. Okay, so these are all the things that you need to try to do whenever you are solving problems. And then, so this is about solving problems, but what I want to focus your attention is to the third point here, which is constructing new problems. So why should you do this, you may wonder. It is for a number of reasons. One is that you come across different ideas, you come across multiple solutions. One important thing that you start to do, as I said, I want you to start thinking of the theorem that you know as problem solving tools. And what you will discover is that every tool or every technique has some ideal range of operation. I mean, to give an example of some completely different domain, I mean, in the real world, you have things such as magnifying glass or a microscope or a telescope. all of them are using lenses of some kind, right? But clearly the telescope is a very different requirement than a microscope. So the same tool can be applied at different scales for different results. So in the same way, you'll discover that all the tools that you have in geometry, algebra, each of them have some ideal conditions that if these conditions are met, then this is the best tool to apply. So you will discover those limits when you start to create new problems. Because what may happen, let's say you are trying to solve a problem using some inequality, A and J inequality. At some point, if you try to create a generalization of your inequality, it will not be solvable using the tool which you already know. So then you will discover that, okay, I need something more powerful, and so on and so forth. Like you can come up with a hierarchy of these tools, that which is more powerful, which is less powerful. Uh, then the third point, which is also very important, is that you get into the problem setter's perspective. That any problem which you are going to attempt in pre-RMO, RMO, anywhere, somebody has constructed that problem with some point of view that I want to test this particular aspect from the student. So if you get into that mindset, then looking at the problem, you can decode that, okay, what is the person trying to test? And you will directly sort of jump 2 steps ahead. Okay, so that will give you a head start. If you have done this process yourself, like constructing problems becomes a second nature. And then another important point is that you help each other, because any problem that you set, you are going to give your fellow students or friends, and they will solve the problem. They will share their problems with you. So you are all going to learn together, and it's a very healthy environment where you are sharing ideas with each other. Because it may come as a surprise to you that you may feel that why should you help somebody else, but when you help somebody else, you are actually helping yourself even more, because the best way to become strong in any topic is to try to teach somebody that topic. So in that spirit, always try to think of these ideas. Okay. So with this diagram in mind, I am already giving you the homework which you are supposed to submit next time. So we are going to go through the questions that you solved for the entrance test. The homework or the task for you is that you try to create, you pick any 3 problems out of those 15, okay, and try to make your own version out of that, some generalization, some variant. Try to sort of add your own spin to the problem. How can you modify the problem in some way? And importantly, it should not be simple like a number change. In school you have this kind of question, like let's say you have simple interest, so PNR upon 100, same formula. If you change the numbers, you get a different question. That is not really a different question. It's just the numbers have changed, right? So I don't expect that. You have to have something new that the person has to do to solve your variant. Okay. And of course, if you can do more than 3 problems, you are always welcome. But at least you should try to do this for some 3 problems. Okay, any 3 problems is fine. And try to submit that document. You can post it on the same WhatsApp group. Importantly, what I'll suggest you to do is you'll post the questions separately and solutions separately. The reason being that if I am reading the question, I don't want to look at the solution accidentally, because that will give away the some idea, right? So it should be that I can just read the question, I try the problem, or anybody can try the problem. If they don't get the problem, then they will look at the solution. Even in that, it's important that you don't directly read the whole solution like a story or something, okay? Because you are trying to improve your problem solving strength. So you should read only one line of the solution. Take that as a hint, try the problem again. Okay. So like that, you are supposed to extract maximum possible value out of the problems. If you do that, then what is more likely to happen is that over time your problem solving strength will improve. And I'm hoping that if let's say we have another entrance test like this in another 4 to 6 weeks, by that time you will be much more stronger. As I already said, you are not going to require any new theory to solve this test paper. It's just that you need to reorient your mind to think in this way. Okay. So I hope all these points are clear. Okay. Okay, so with that, let's get into the problems. So what I did was, I was trying to figure out in what order I should discuss the problems. I would go from question 1 to question 15, but as it so happens, I was just looking at the data that out of this particular group of 31 students, which problems have been successfully solved by majority students and which have been solved by less. So here on this graph, actually the x-axis is the question number and y-axis is the percentage, that what percentage of students have solved that problem correctly. So as I see, first three problems, more than 50% students have solved correctly. So I'm going to skip them straight away, and I'm just going to start from question 10, and from there we'll go down the chart. Okay, so that is what I want to do. And at all points of time, I want us to focus on the idea about what is the strategy that you're trying to solve. I mean, many cases it might be that you have solved the question also correctly, but you did not think of it in a particular strategy. Maybe you just tried a few things randomly and you got the answer. What you have to do is think of what is the strategy, what is the clue in the question from which you figure out that okay, this is what I want to try. Okay, so this is the focus for our lecture. Okay, so let's start with question 10. Okay, so like standard algebra kind of question where you have some data given. So first thing that you always should try to do when you are presented with a question like this is figure out what are the given variables, what is it that you want to find out, and how to go from what you know to what you need to find out. Okay, so if you are given x square plus y square and you are supposed to find x plus y. Now clearly this is a question of two variables and two unknowns, right? So in theory it should be possible to do that, although it's not linear, but it should be possible to do that. The question is, what are the two unknowns that you will try to pursue? Are you going to try and find values of x and y, or is there something better that you can do? So those who got the problem, can you suggest any idea?
X plus y and xy.
Yes, sir. X plus y and xy.
X plus y and xy, correct? Because both of these expressions are what we call symmetric expressions or symmetric polynomials, in fact. Okay. So for those who are not aware of this concept, actually, basically symmetric means that if I exchange x and y in both the expression, the value remains unchanged. So whenever you have polynomials of this kind, you can always express them in terms of what we call elementary symmetric polynomials. By the way, I mean, these terms may, if you have not heard them before, may seem that I'm introducing a lot of theory, but it's actually just the common sense which all of us may already be aware of that. So basically here x plus y and xy should be the fundamental variables. And so you rewrite the question in terms of these two variables. So maybe x plus y is s and xy is p. And now with some basic algebra, you can see how to rewrite these two things in terms of s and p. So your unknown variables are not x and y, it is s and p. Okay, so I mean, in terms of the strategy, what is the strategy here? It's change of variables. Okay, that you choose the right set of variables and you go into that frame of reference, and then that will help you solve the problem. Even in x and y, you can solve the problem. It's not that it's impossible, but you are going to make your. Can you hear me?
Yes.
Okay, I think I lost connection for a minute. So that is the whole idea. Now the details are not that important. I think everybody can figure it out. That x square plus y square is basically s square minus 2p, and x cube plus y cube, which is x plus y times x square minus xy plus y square. So this is s into s square minus 3p. Okay. So this is the second point that we have to think about. Again, now we still have two unknowns and two equations. So in a way, it may seem that we have not solved anything. I mean, we know the values of s square minus 2p and this expression. But here the second idea comes, which is going to be there all the time, which is reduce the number of independent variables. Or in other words, eliminate wherever possible. So in these two expressions, I think what you can see is that I can importantly p is linear over here. So the fact that p is linear, which means that it is much easier to substitute p into the second equation. Okay. So if you eliminate P from both of these equations, you will end up with a cubic in S. Okay. So in general, when you have a cubic, you cannot directly solve it. I mean, there are ways to do that, but they are generally beyond the scope of what we are studying. But this is where you have to sort of understand that, how do I say it, get into the examiner's head that at the best I can call it meta thinking. Okay. So what is meta thinking? The fact that, okay, you have been given a cubic and you can assume that the examiner expects you to solve the question, which means you can expect that that cubic will have some nice roots. Okay, so therefore you start trying some nice roots. So if you try s equal to 1, you will directly get it that that is a valid root. But in case maybe somebody wants to design a bit harder question, you try s equal to 1 plus minus 1 plus minus 2 plus minus half. Okay, so these are kind of the standard routes which somebody can try, and hopefully one of them will work out. Okay, I mean, for the most part, you can assume that the examiner will not try to ask a question which goes beyond this. Okay, so this is where you have to keep in mind that the question you are trying to solve should be solvable. So, given the fact that the question is solvable, what is the best guess that you can give? Okay, so that is what this is. And then, I mean, the rest of the part is doable because the remaining quadratic equation doesn't have any rational roots. So that is where the question is over. Okay, but see what I did. I didn't solve the question in front of you because I trust everybody can do the calculation. What I outlined was the roadmap, that what are the important steps that you need to reach in order to solve the question. And this is what you need to be thinking about, because some different questions may come where the details are different, but the roadmap is quite the same, that you need to use the right number of variables, go into the right frame of reference, and then do some meta thinking. So this is what you need to learn more than the details. Okay. Any questions, or does anybody have a completely different approach to solving this problem? Okay, if not, then let's go to the next problem. So question 4. Okay, find the number of 3-digit numbers which are divisible by 11 and whose digits are all odd numbers. So can somebody explain to me what would be your strategy? How do you try to approach a question like this? Anushka, go ahead.
Yes, so what I did is that the divisibility test of 11 is that the sum of the like even digits, 9 is the sum of the odd digits should be 0 or some multiple of 11.
Right.
So if it cannot be 0 because all the 3 digits have to be odd. So like
Yes,
sum of
yes.
one set will be even and one will be odd. So we cannot get a 0. So it
Right.
will be some multiple of 11. So let us take like some odd multiple of 11. So 11 times 1. So we
Okay.
just try to fix a 1 or 2 one digit and then try to find what the rest of the digits can be.
I didn't get the last point. So what you said is correct, that the, suppose I call the number ABC. Okay, so then A plus C minus B, this is the expression we are looking at, correct? And this has to be either 0 or some multiple of 11. And what you correctly pointed out, that it cannot be 0 because the odd plus odd minus odd cannot be even. So therefore it has to be a multiple of even, 11. What did you say after that?
So we'll try to fix one digit, like say 1C is 3. So it cannot be 1 because then A has to be like more than equal to 10. So
Okay.
C start from 3, say. Then
Okay.
A we can start from say 9. So we'll
Okay.
get 9, 1, 3.
Okay.
Then we can
Okay.
fix C as 5 and then try to find, then we'll get start with A as 9. So 9, then 3, 5, and
Okay.
then 7, 1, 5, like that.
Okay. This will work out, but I'm wondering if this will require too much trial and error. That, can you think of a way where we reduce the trial and error even further? Because here, for every value of C, in theory, A has 5 values possible, B has 5 values possible. So total 25 things to try. So is that really necessary, or we can do something more efficient? Anybody else has any suggestions?
Sir, I think if we do only till 5, then we can get the rest of them by symmetry.
Okay, so where do we start?
Yeah, maybe starting point as 3 is okay, then 3, 5. I think we did not go to 7 because that will be covered in 5.
No, I didn't get it. So we are talking about the units place digit, right?
Yes, sir.
So if 3 is counted, why won't you have to count 7 again?
Sir, because if you count 7, then 7 will sometimes be in the A, the value of A will sometimes be 7. So that's all that has already been count. Like we just flip the number.
Oh, no. I mean, the cases which I am making here are about the units place. So if unit place has been 3, it can be 7 separately, right? So
Yes, sir. I am saying that we need not count beyond 5 because then we can just flip all the numbers and get the remaining numbers.
we can sweep. I didn't get what you mean by sweep.
Like, sir, 913, if we flip, we get 319.
Oh, okay, I see. Okay, okay. Interesting. But the thing is,
No, sir.
I'm not sure whether you can be sure this strategy is foolproof.
Sir, 979 does not satisfy this.
979, or in general, I mean, what I'm concerned about is you are assuming that there's a one-to-one correspondence between every number that ends with 3 and every number that ends with 7. But maybe one set is larger than the other, so I'm not sure if
Yes,
that
sir.
will always work out.
Yes, sir.
Anybody else? Garu?
That had a similar approach.
I can't hear you. Okay, but just to give you an idea about how I could approach the question. So first thing which you have understood is that a plus c minus b cannot be 0. So let's continue that train of thought before trying to jump into the actual cases. So again, this is the strategy which I'll highlight here. That I mean, we want to do trial and error eventually. That's true, but try to constrain the problem as much as possible. Okay. Try to reduce the number of trial and error cases before you start the trial and error. Okay. So what we can do here is, so a plus c minus b can be 11. That is one possibility. Can it be 22 or anything greater than 22 for that matter?
No, sir.
It cannot be. Fundamentally, because A, C, B are all digits, right? They are in the range 0 to 9. So A plus C itself can never exceed 17 or 18 rather. So therefore, A plus C minus B as a whole, the only possibility is A plus B minus A plus C minus B is equal to 11. So we have to stop there. And now in this we know that B is odd. So if I take this to one side, this is A plus C equal to B plus 11, where this is an even number, correct? And what are the even numbers which are possible? So if you think about it, it's actually, so B can be 1, 2, 4, 1, 3, 5, 7. So B can be 1, 3, 5, 7. And in each case, the B plus 11 can be 12, 14, 16, 18. These are the only possible values. B cannot be equal to 9 also, because as soon as B is equal to 9, the RHS is too big. A plus C can never be equal to 20, right? So now we have defined the cases that, so if I have to write this properly, by the way, I mean, when you're solving this in the pre-RMO kind of exam, you don't write the full details, but here because I'm explaining, I'll write maybe case 1, B plus 11 equal to 12. Case 2, B plus 11 equal to 14. Similarly, 16 and 18. Okay. So these are the 4 cases I need to look at. And in each case, what I know is A plus C is equal to the same thing. So I just need to do the trial and error for A plus C. And actually, this is where Arnav, your idea comes valuable. Now I can be sure that symmetry is going to work. Because here, for example, just take the first case, 12, right? So 12 is what? 3 plus 9. And the only other possibility is 5 plus 7. And now you can see that by symmetry, 9 plus 3 and 7 plus 5 is also going to be there. So the case 1 has total 4 possibilities. Right? What about case 2? So this can be not even 3. So it
You
has to
won't
start
work. So
from
we'll start with 5.
5
5
plus
plus 9.
9 plus 5 and 7 plus 7. Okay. So like that you can proceed. I think here you get 2 and here you get 1. So in all you get 10 numbers. So I hope everybody appreciates two things. First is that I did not use any new theory which nobody knew. Everybody knows the theory. The question is how do you convert that theory into problem solving ideas? So you can note down whatever you want, but as I said, the important thing that you need to look at is the strategy. That focusing our attention on a plus c minus b was the first step. We reduced the number of possibilities of a plus c minus b, and we found that there is only one possibility which is valid, 11. We used that as a basis to make the cases, and the cases were of the just the right size, bite size case. That each case is very simple to solve, and you can combine all of them to get the answer. So that was a very nice dissection of the problem. And then there was nothing left to it. Once you take care of these things, it's going to be straightforward. Okay, so I hope by looking at these problems, you are getting the feeling that I could have done this. Even if you didn't get this question in the paper, there is time constraint and everything, but given enough time at home, you can try and get these ideas. You have to build that confidence, and your problem solving will naturally improve. Okay, next question, 15. Question 15 was a learning experience for me, honestly, because you can imagine it's the last question of the exam. I thought this was the hardest question, but clearly I was wrong because there are other questions which people could not try. So what went wrong from my perspective? This always happens that I have one solution in mind, but there is always some alternate solution which is easier, which I completely missed. So can anybody share what is your solution to this question 15? Shubhankar?
Sir, yes, sir. Sir, I assumed first value as m and then divided by 2 plus 5.
Okay.
And I then multiplied it m plus 10 by 4. Like I simply considered what will be the fifth value.
You
That
mean m plus 10 by 2, right?
yes, yes, sir.
Okay. Okay. Continue.
Again divided by 2 and plus 5. So
Okay.
till case 5 I completed it, and then I used multiples of 32,
Okay.
nearest multiple of 32, and so smallest value of 5 m.
Okay. Got it. Does anybody know what is that expression at the fifth stage? What do you get finally? Can somebody quickly tell
m
me?
plus 310 upon 32.
Sorry, can you repeat that?
M plus 310 upon 32.
Say 30. Correct. So this is the value you get at the fifth point, and the expectation of this should be an odd number, right? Then the game will end. So therefore, clearly, I mean, this if you set it to be 11, then you get the value of m is 40. Okay.
Sir, I had a different
Can you
idea.
raise your hand if you did the same thing? Or rather, raise your hand if you did something different. If you have any alternate way. Anybody? Arnav, Anushka, any alternate way?
Yes, sir.
Okay, go ahead.
Sir, I just did some trial and error.
Okay.
So I assume the numbers to be A, B, C, D, E, F. The sixth number is odd. So
Okay.
F is also E will be even because the by 2 into 2.
Okay.
Then E by 2 is even, so E should be at least 4. And I went on getting some least numbers, and finally
Okay.
I got the least number as 11.
Okay. Okay.
Sir, I started from the smallest number, add -5 in times 2, and went up till the sixth move, and then we get the smallest number as 42, something like that.
Okay. Yeah. So all of them are valid ideas, and see, finally, what matters is solving the question. So I mean, all credit to you that you found the way to solve the question, and that is what finally matters more than anything else. That in cricket, even if there is a bouncer and you just flick it, it goes to a 6 and 6 runs. Although that's not a technically very good shot, but you still get the score. So very well for that. But now we have to think about the mathematics behind this. That I mean, I stopped this question at the fifth move. What if I had asked you about the 500th move? Are you going to keep doing that by 2 plus 10, like by 2 plus 10? Can you do something better? Okay, so that is what, let's think about it now. So as a first step, let's establish some common notation. Okay, so this is the notation which I would like us to try. So let xt be the value after pth move. Okay, so in this way, x0, that is the start of the game, before even one move is played, the value is m. Then x1 is m plus 10 by 2. x2 is, I think, m plus 30 by 4, etc. Correct? So in this way, you correctly found out that x5 is m plus 310 by 32. So as a first question for you, try to find the formula for xt. Okay, any general term in this series, can you try to find the formula? Okay, I'll give a few minutes to think right now. You can try this with a fresh mind. Raghav, you already have an answer?
Yes, sir.
Okay, we'll just wait for everybody else to try.
Okay, sir.
Yeah, I see a few other hands are also there. So, so Raghav, don't tell the solution, but can you just give one line hint for others that how did you start?
Sure. So like what I did was like I did not like solve like now if you do m plus m over 2 plus 5, if we simplify it, you get m over m plus 10, which is basically 5 times 2. So I did not solve the 5 times 2 and I just did the process again and again. And like if you see there's a pattern over there.
Okay. Okay, so I see many hands are up. I hope that we have different approaches. So, okay, Raghav, so you can explain in more detail what we should write first.
Yes, sir. So like if our first x1 will be m over 2 plus 5,
Okay,
which is basically m plus 5 times 2 over 2.
correct.
Now x2 will be m plus 5 times 2 over 2 over 4 plus 5.
Correct.
This becomes m plus 5 times 2 plus 5 times 4 over 4.
Okay.
Now, if you observe this pattern, if you do it for more steps, you'll observe that you will get m plus 5 times 2 to the power 1 plus 2 to the power 2 all the way to 2 to the power t over
Right.
2 to the power t.
Correct. So basically
And
5 will come out common, and inside you have 2 raised to 1 plus 2 raised to 2 plus 2 raised to t, correct?
Yes.
And whole thing upon 2 raised to t.
Yes.
Can we simplify this further?
Yes, sir. You will get 2 times 2 raised to t minus 1. No, sir. Like, not like, it will be like 5 into 2 into in bracket 2 raised to t minus 1.
Okay, yeah, sure. That is also fine.
Essentially 10 times.
Yeah, 10 times.
Yes,
Yeah,
sir.
we
10
can
times 2 raised to t minus 1.
2 raised to t minus 1 upon 2 raised to t.
1 to the power t. Yes.
Okay, does everybody agree with this answer? Maybe
Yes, sir.
like denominator adjustment, maybe split it into 2 fractions, but basically, is this the correct answer?
Yes, sir.
Okay. Anybody else has a different approach? Or no?
No, sir.
No.
Same geometric progression.
Okay, so everybody observed the same geometric progression and did that. Okay, so the first question is that looking at the pattern, it seems certainly that xt has this formula, but how can you be sure? So we need to prove that xt is this formula. So there are 2 ways to do that. One is basically we have to use some kind of induction. That finally, what can you tell me about the connection between xt and xt plus 1? What is xt plus 1 in terms of xt?
By 2 plus 5.
Xt plus 10 by 2, correct?
Yes, sir.
Yes.
Okay, so this is we have, I don't know if you have studied this formally, but this is what we call the recurrence relation. Okay, so when you have a series of numbers, this is how the next term is related to the previous terms. So this topic will be done formally by us also, but just to give you the idea. So one approach is that we have to use induction. So when we say by induction, what do we mean? That this is my claim. So my claim is that this is the formula. This is the formula for xt for all natural numbers t. So what induction involves is 2 steps. So induction, first you have to solve the base. Prove that star is true for t equal to 1. Okay, which in many cases is trivial. So here also it is trivial that for t equal to 1 this formula clearly works. And the second is the induction step. So prove that if star is true for some t, then also true for t plus 1. Okay, so given that xt is given by this expression and given this recurrence relation, can you see that xt plus 1 also satisfies the same formula? If you can show that, then you have completed all the steps. Okay, then finally the thing is, just by observing a pattern, you are hoping that it is going to be correct, but who knows, there might be some reason why this pattern breaks after a point. So unless you are given the formal proof, you can never be sure. And in fact, maybe in another lecture I'll show you some examples where we can be very easily fooled that there is a pattern which very nicely works for 100 numbers, 200 numbers, but after a point that pattern stops working. So this kind of things do happen. So that is why you need a formal proof. Okay. So induction is one way to do that. Okay. I am not going to the details. I hope everybody can substitute the value of xt in this expression and verify that xt plus 1 also has the same form. Okay. So this is one way to do it, certainly. Look at the pattern, make a guess, but then importantly prove your guess. I am going to show a very different approach also, and it might seem like a bit of magic, but you'll suddenly see that there is something very nice that you can do with this expression. So my starting point is this recurrence relation, xt plus 1 equal to xt plus 10 by 2. And I mean, to be honest, the fact that you can do this comes with some experience. I understand that you cannot directly see why this will happen, but slowly you will build the confidence that you know you can do something like this. The key idea, if I want to give it as a name of a strategy, is restore the form. Okay. So this is like one of those magic phrases that restore the form. We have to decode what that means, and I think this is a perfect example to illustrate. As it stands right now, see the LHS and RHS, they both have xt, so xt and xt plus 1. But the form is completely different. On the RHS, you have something plus 10 by 2, and on the LHS, you have simply xt plus 1. So they are not symmetric in that way. But can we do something by which they look very similar? Xt plus 1, the LHS looks very similar to the RHS. That's what I want to do. So the way I see this expression is the LHS is actually having some plus term, but that term is simply 0. So I am just thinking of this as xt plus 1 plus 0 is equal to xt plus 10 by 2. So this sort of plus 0 is implicit over there, and clearly on the LHS the plus 0 is there, on the RHS there is no plus 0. So if I were to do something clever and make this whatever constant which is there equal, can I add or subtract something by which this whatever constant is there will become equal? See, in general, if let's say something completely different, let's say a plus 0 equal to b plus 10. Suppose this is the expression you are given. There is nothing you can do which will make this 0 and 10 equal, right? Because if you subtract k from here, you will subtract k from here also. So this expression and this expression will always never be equal, no matter what k you select. But the specialty here is that there is a upon 2 over here.
Sir, minus 10, I think, sir, we should subtract.
Minus 10. Okay. So what happens if I do minus 10? So I get xt plus 1 minus 10 equal to, what is RHS?
xt minus 10 by 2.
Okay. Do you see what has happened? See, this expression as a whole motivates me to think, why don't I define a new term yt which is xt minus 10? Okay. If I do that, do you see that LHS is simply yt plus 1 and RHS is yt by 2? So now do you see what is a very quick way to find a formula for yt? Because this chain will continue, right? So yt by 2 will be yt minus 1 by 4. Yt
Symmetric progression.
So what is yt? So all the way down to y0 upon 2 raised to t. T plus 1, sorry. And so what is the value of y0 by the way? M minus 10.
M minus 10.
So that directly gives me a formula. So xt is equal to, and by the way, whenever you write an expression like this, which gives you how to go from xt to yt, you can always reverse it and get the expression for xt. So xt is yt plus 10. So therefore xt is equal to m minus 10 by 2 raised to t plus 10. And you can verify that this formula is the same one as what you found from the pattern. So the magical thing here is I did not have to look at the pattern at all. I did not have to look at the pattern and guess the geometric progression. from this expression, this recurrence relation, directly I could do all of this analysis. Okay, and the thing is, why is this important? Why is this alternate solution important? For the simple reason that tomorrow you may have a problem where the pattern is not so easy to guess. You may write down the first 3, 4, 5, 10 expressions and you cannot guess the pattern. So then you need some analytical tool like this to crack the problem. Okay, so both approaches are useful in their own right. So that's what I was saying earlier, that every problem solving tool has a set of ideal conditions where you can apply it. Here the ideal condition was that the coefficient of xt plus 1 and xt was different. Okay, here the coefficient was implicitly 1 times xt plus 1 and here the coefficient was half. That the asymmetry of the coefficient allowed us to choose a clever value of like some subtraction which allowed the form to be restored. Okay. So make a careful note of that these are the conditions under which such an idea can be applied. Okay, so with this inspiration, do you see that you can now try a different problem? Maybe in some other question, the recurrence relation could be 80 equal to 80 minus 1 plus 1000 by 3. Doesn't matter what the constants are. Do you see in your mind that with some clever adjustment, you can restore the form and get this to work also? Okay, so I'm just giving you ideas that how you can create your own problems. Okay, and let's see if somebody comes up with some clever problem which uses similar ideas. So all the best for that. Okay, but the key idea is restore the form. Any other comments about this question? Okay, but yeah, like I said, for me also this was a learning value that maybe this should not have been question 15 on the test, but as it is. Okay, question 9. Find area of a rhombus given the distance. What is the strategy for this question?
Sir, the simplification of variables.
Simplification of variables. Yeah, that is one way to look at it. The way I would phrase this question is, it is actually only Pythagoras theorem. Everybody knows Pythagoras theorem. Just because there is a rhombus doesn't seem like there is Pythagoras theorem, but that's all that is happening. So the information given to you is the distance between opposite sides is 12. This is 12, and the sum of the diagonals is 35. So if I call the diagonal sum 2x and 2y, then 2x plus 2y is equal to 35. And the distance between the opposite this thing is 12. Okay. So, Arnav, can you expand on your idea? What should we start with?
Yes, sir. So we should start with x square plus y square is equal, root of x square plus y square is the side. And then we can relate the area xy by 2 is equal to 13 times the side.
Yeah, correct. So basically, if we introduce one auxiliary variable, so in a way, it may seem that we are going against our advice. That earlier, I said that we should reduce the variables, but right now introduced a new variable z for one side. So it seems that we have temporarily increased my load, but the important thing is it is only temporary. Okay, I mean just to keep things organized and adding the variable z, we are going to eliminate it very soon. But because the length of the side is relating to both the x and y as well as the area of the rhombus. So that is why it's a good idea to introduce the variable z. So the area of the rhombus, if I call it s, which is basically 12 into z, okay, and which is given to me. What's the value? Oh no, sorry, I have to find this. But what I know is that I can also find the area in terms of the product of the diagonals, right? So therefore, this is also equal to 2xy. Okay. So you see, I have 3 unknowns and 3 variables, so I can solve this question. We just need to eliminate the z variable, and you'll get everything in terms of x and y. But of course, you can do this and you'll get the answer. What I want to direct your attention is that actually this is the Pythagorean triangle just hidden in plain sight. What if you build this? Okay. let me just draw the diagram again. It's not. Let's call this a rhombus. It's not exactly nice looking, but what if I did this? The diagonal AC, right? If I just translate it to the right and make it basically parallel to itself like this, okay, and look at this triangle BC dash D, okay, which is a right angle triangle, and basically what I've given to you is the sum of its two sides is given and this height is given, okay. So if I earlier I called them 2x and 2y, let me call it x and y now. So this is x and y. So what I'm giving you is x plus y is given. And do you already know some property which relates x, y, and h from your standard, whatever you have studied? Can somebody tell?
1 upon x square plus 1 upon y square is equals to 1 upon x square.
1 upon h square. So you see now I don't even require that third variable z. I have everything here. Okay. Now I mean you can simplify this on the left side, and you will get what you want. Okay. So in this x plus y can be substituted, and then you have expression purely in terms of x y, and it turns out to be a quadratic, so you can solve it. Okay. So just how you can look at the problem differently and get a different approach. Okay. So I mean, from those who were not able to solve this question, I want to hear from you that where did you get stuck? That is it that you could do all these things, but you made a calculation error, or you somehow did not realize that this approach is possible at all? So what was the bottleneck? Either of those solutions, the first solution or the second solution. Either way, if you ask me, this was a doable problem, but I mean, from the data, what I see is that only around 30, only 1/3 of the current batch got this problem. So for those who did not get this problem, where did you get stuck? Because I have to understand, is it time constraint, or is it a calculation error, or a conceptual error?
Sir, I tried using the first method, but I thought that the calculations were getting a bit tedious, so I just left that to after the end. But at the end, I did not get time.
Okay. Okay.
Yes, sir. Same for me.
Okay. Okay.
Same for me.
Excuse me, sir.
Yeah, go ahead.
So could you please confirm the answer to this question?
The answer is 150, right? No, well, yeah, 150.
Okay, thank you.
Yeah, because basically it turns out to be a, I mean, this triangle which I'm talking about is of the size 20, 15, 35, or 25. Sorry. Therefore, the product of the diagonals is 300, so the area of the rhombus is 150. Okay, yeah, I mean, if it's time constraint, then it's not so much of a reason to worry. I mean,
Sir, I got this after the exam, in using the
okay.
first method.
Okay, that is fine. See, I mean, what happens is, to be honest, I know the numbers were slightly big for this question, but if I give some very obvious, like 3, 4, 5 triangle, then everybody can guess the answer without even writing any calculation. So to avoid that, I have to unfortunately give slightly big numbers. That's what happened for this question. Okay, so that's question 9. Question 13. Okay. Question 13 is again what I put into the category of meta thinking. So what is the meta thinking to be done here? See, clearly there are 4 unknowns and I am giving you only one equation. In any normal situation, there is no way that there will be a unique solution, right? There will be so many, the degree of freedom is so vast. And how am I asking the value of some a by b plus b by c? So there are only 2 possibilities. One is that equation directly can be simplified into the final answer. Or if not, there for some reason, the degree of freedom is only an illusion. In reality, the degree of freedom is very, very less. Okay, so one of those 2 things has to happen. So in this case, I mean, just to motivate what what is the style of this question? I mean, if I were to design a simpler question of the same flavor to give you an idea that why is this question doable? Suppose I ask you that given, so I mean, think of this as a completely new question. Okay? Suppose I say that given some real numbers a and b such that a square minus 2ab plus b square is equal to 0, and find the value of a value. What is the answer?
1.
So that is the one line hint for what is the kind of question this is. That the fact that a b are real numbers means that a minus b whole square 0 forces a equal to b. So I just took that simple theme and disguised it a little bit. Okay. So now knowing this fact, take a second look at the question. And do you see what is happening? And I mean, this is again for those who were not able to solve it. Can you see that it is a bit more disguised, obviously, but the idea is the same. Okay, so this is how you start to deconstruct the problem. So I'm thinking a lot. Right? Suppose I were a student and looking at this question, what do I see? On the RHS, I see some middle terms. It's very looking like a plus b whole square kind of thing. That LHS is nicely a square plus something b square, and RHS is looking like the middle terms a b b c c d d a. But clearly, as it stands right now, there is a mismatch, right? I mean, a square minus 2ab plus 4b square makes no sense. So some adjustment is needed. And the key idea is that there are 4 middle terms on the right hand side. So there should be 4 brackets of this kind, something minus something whole square. I need 4 such brackets. And if I need 4 such brackets, then that means I need 8 such perfect squares, right? Because every bracket will have a square and something b square. So on the LHS, I need total 8 such terms. But I have been only given 4 terms. So the simple idea is, why don't I just double everything? Okay. So if this is what is given to me, okay, and as I said on the LHS, I would like 4 more terms, please. So let's just multiply everything by 2. So I'll get 2 copies of a square, 2 copies of everything. And on the RHS, what will happen? Everything will become 4ab, 4bc, 4c, and 4da. And look at that. Now, do you see what's going to happen? Very nicely, everything is lining up because this a square minus 4b square will nicely pair up with this middle term, and so on and so forth. Therefore, when you take everything to one side, this is simply going to be a minus 2b square plus 2b minus c square plus c minus 2d square plus 2d minus a square is equal to 0. And so, what you can clearly see, and importantly, because a, b, c, d are all going to be real numbers. Therefore, the sum of 4 perfect square is 0, which means that each of them is 0. And therefore, in fact, what you have is a is equal to 2b equal to c equal to 2d. And then you can solve the problem. Okay, everybody following? Okay. But the key starting point was realizing that what the examiner is asking is impossible in a general sense. So there must be some trick involved. Okay, that is the first thing that you have to realize. That there has to be some trick involved, otherwise this question is simply insolvable. In any general condition like that, you will have infinitely many pairs of ABCD which satisfy. Okay, I hope everybody did it with the same method, or is there any other approach available? No. Okay. Okay. So I hope I'm giving you a lot of ideas about how you can create questions based on the themes and topics that we are talking about. There are so many ways in which you can sort of repurpose these ideas and come up with your own questions. So I really hope everybody can submit something on the group. So if you have 30 students and everybody submits 3 questions, see, we'll have a database of 100 unique questions for everybody to try. So it is going to be helpful for everybody. Okay, next question. Question 14. So in geometry questions like this, right, it's always, and in general, this is true for all Olympiad questions, you can say that the difficulty is never in terms of, you know, you have to apply something very complicated. It's simple steps from start to end, which will lead you to the solution. The difficulty is finding what are those middle milestones. That okay, what is the first intermediate step, what is the second intermediate step, and then what is the final answer. See, if I give you those intermediate steps, I can break this question 14 into 3 subparts. Okay, subpart A, subpart B, subpart C. Everybody will get this problem. But with your own problem solving experience, you have to build that intuition to guess what are those intermediate subparts. So here, for example, what is given? Oh, I think A was supposed to be AB was supposed to be larger in size. Let legitimate point of size. Okay, so this is the diagram we want to do. So where AFDC and ABD are cyclic. And we have given Fk and finding K. So how do you start thinking about a question like this? See, clearly Fk and K are being related in some way, and you see an angle bisector there. So what is the first step that should come to mind?
Sir, angle bisector theorem.
Angle bisector theorem. So Fd upon dE is equal to Fk upon K. So if I find Fd upon dE, am I done? Okay. So that is the first milestone. Okay. So the question is no longer find K. The question is find Fd upon dE. Okay. Why is this important? Because now you don't have to worry about the point K at all. You can simply delete the point K from your diagram. So you have simplified your question. You know, so you start getting rid of things that you don't care about. Okay. So I'll actually erase K from my diagram completely. Okay. So you realize how powerful this is, that you can keep doing this. Okay. So I need to go to Fd upon dE. What is given to me is this cyclic property. So by the way, cyclic means that these angles are equal. So when you are talking about ratios, what is the natural related ideas to ratios that come?
Similarity.
Similarity, where you can chase ratios, right? This ratio equal to that ratio. So some similarity is there. And do you see similar triangles in the diagram?
Yeah, yes, FBD and EDC. I guess.
Yeah. So FBD will be similar to, and this is going to be similar to. So all these three triangles are similar by virtue of the angles which I have just marked. So I mean, this angle A is equal to here, and of course these are common angles. Okay. So now we have to see that from these similarities, is there some way to reach FD upon dE? So here you realize that directly there is no way, because FBD and these two triangles which have the FD upon dE, they are going to give you the product FD into dE. Okay, not the ratio that we need. So we have to make use of this intermediate in some way. So if you look at the first two triangles, I can write FD upon CA is equal to something. So for example, I can write BD upon DA. And from the second pair, what I can write? ED upon DA is equal to. Again, see, note why am I writing this pair? See, in a triangle, I have three pairs of similar sides. But my particular interest is in BD and DC because I know they are equal. So therefore, I prefer to write the pair where BD and DC are occurring. Okay. And so what will happen now? I have FD over here and I have ED over here, but I want their ratios. So what can I do?
So divide these.
So we
two
can just
ratios.
divide the two
You can divide
equations.
the both ratios.
I can
Well,
just
we
divide.
can-
CD will get cancelled and we know AC and BC.
Exactly. So we are done. So before doing that, maybe just refresh this. So I'll take CA on this side, and I'll take BA on this side. Okay. And now when I divide, I get FD upon DB is equal to. So as you correctly pointed out, BD and DC are going to get cancelled. And so what am I going to be left with? CA upon AB into CA upon AB. In fact. So it is actually CA upon AB whole square. And now we know everything CA and AB is given to me, right?
Yes, sir, they are given 64 and 80.
Yeah, okay. So you can complete the calculation. Okay, so for those who didn't get this problem, just think again that was there anything that you didn't know here? Everybody knows similarity, everybody knows the angle bisector theorem. What was not given is the fact that these are the intermediate steps. So do you see what I mean by, suppose I give you this as three subparts. Part A, prove that these three triangles are similar. Part B, show that this is true. And then part C, find the value of K. Then everybody will get it. But the fact that these subparts are not explicitly mentioned is what makes this problem hard, so to say. Okay. So with your experience, you have to guess that these are the intermediate steps. And the more problems you solve, the automatically you will become better at doing this. Okay, question 14. Now question 7. Question 7 was solved by around 20% of the students. So what is hard about question 7?
So can you tell the answer for this question?
Which question?
Question 7.
Question 7, the answer is 3, right?
Yes, sir.
Yes, sir, 3.
Did anybody get the answer as 13?
Yes.
Yes.
Sir,
So
At first I was getting 13, but k is equal to 10 is getting infinitely many.
yes, yeah. So that was the trick. Where I mean, there is always some twist involved in a question like this. See, if something is too good to be true, then maybe it is not that good. So always beware that question which look deceptively simple may be throwing a googly at you, and you have to be more careful.
Yes, sir,
Okay.
3 and 10 were the possible answers, but then for
Yeah.
k equal to 10, we were getting that's infinitely many solutions.
Yeah. Okay. So yeah, I mean that as long as you are clever enough to spot that, or rather alert enough to spot that, you should be able to solve this question. So I mean, multiple ways to do this. For those who are a bit advanced, they know maybe Kramer's rule. They can directly write a determinant of this LHS, and the determinant is k minus 6 times k minus 7 minus 12 is equal to 0. So from that you can directly get k equal to 3 or k equal to 10. And then these are the possibilities, but you have to back substitute and check which of the possibilities are leading to infinite solutions and no solutions at all. But I mean, for those who don't know this idea of determinants, you can simply eliminate just the way you do it normally. So let's say you want to eliminate y. So I'll multiply the first expression by k minus 7 and the second expression by 2 and subtract. Okay. So when I do that, I'll get basically same thing, x times this polynomial on the right side, which I'm showing. Is equal to some expression on the right side, doesn't matter.
Sir, or we can consider the equation as lines, and we will get k where the lines will be parallel as the.
Right.
Yes, sir. Yes, sir.
Yeah, correct. So in that case, basically we'll be looking at the slope of the two lines, right? Where the slope is equal. Correct. So again, in different ways, you are going to do the same thing. Ultimately, you will come to the same polynomial, which I'm showing on the right side. Correct?
Yes, sir, and the other solution of k gives the lines coincident, so we should not consider that.
Yeah.
Yes,
correct.
sir.
Exactly. Okay. So multiple ways to approach the problem, but I mean, once you get the possibility that k is equal to 3 or k equal to 10, and that's why in fact I posed the question like, you know what I did there? Find the sum of all k. See, if I just told you find the value of k such that something is true, and then you are getting two possible values, immediately your antenna will be alert that obviously there cannot be two answers, so one of them has to be invalid, and then you'll be more alert. But I asked the sum deliberately because then that may mislead you to think that maybe both of them are true. K equal to 3 and k equal to 10 both are true. And you'll quickly, to save time, you'll write 13 and you'll move on to the next problem. And that is where you'll get caught. Okay, so you should know all these traps which examiners set for you, and you should avoid them carefully. Okay? So obviously, if there's only one value of k possible, what is the point of saying find the sum? So this is something that I hope you can use some tricks like this to get your fellow students. But more closely looking at what happens when k equal to 10. So as somebody correctly pointed out, when k equal to 10, the two equations are perfectly identical. So the first expression is 4x plus 2y equal to 2, and the second is 6x plus 3y equal to 3. So you see that these are just direct multiple of each other. So any x comma y pair which satisfies the first equation will automatically satisfy the second equation. Okay, so that is why that case is not valid. Okay, any other comments about this question? Okay. By the way, related to this, there is a rather standard question that gets asked around in MPI often, and in fact, Prakash sir started this trend, I would say, that given some real numbers a comma b, solve completely x equal to b for x in u. Have you come across this question?
Yes, sir.
Okay, so the important word is solve completely, because you may quickly write x equal to b upon a and move on, but you are not taking into account all the possible values of a and b. Okay, so if everybody is acutely aware of the full sort of analysis of this question, then you will have no problem in understanding what is going on with this question separately. Okay. Okay. Next question, question 11. Okay, again, question 11 is actually just Pythagoras theorem. As it so happens, the question is kind of wrong, because in fact, Prakash sir pointed this to me that can you find the flaw in this question? Anybody? It's a very subtle point, and I also completely missed that. Turns out that any value of r is a valid solution. What do I mean by that? Any value of r is a valid solution, any positive value, of course. How can that be? So I guess everybody must have drawn a diagram like this, right? So there is one circle like this, another circle like this, and then the two circles which are tangent to each other of equal radius, something like this, correct? The diagram is not very accurate, but something like this. Everybody must have drawn a diagram like this. Is there a different diagram possible?
Sir, we can draw the second circle outside.
Outside? Where?
Sir, at the intersection of the third and the first and the third.
Wait. Let me draw the diagram properly. So what is called? Okay, so 10. Where should I draw? So this is gamma 1 and gamma 2. So where should I draw gamma 3 and gamma 4?
Inside the circles.
Okay. I mean, just the way I drawn them earlier or somewhere else?
Sir, I think I got the flaw.
Okay, tell me.
Maybe
Sir,
you should
AB is the
write that.
diameter.
Okay, so
So A and B should be A should be on the circle, no?
no, A is the diameter of gamma 1, right? What's the problem with that?
No, sir. No, sir. I
I
was
think I
thinking.
found the flaw.
Okay, tell me.
Sir, I think gamma 3 and gamma 4 can lie on each other.
Uh,
No, but
no, let's say
both the
we know they are
tangent to
distinct
each other.
circles.
They totally lie on each other.
Lie on each
Maybe
other
then.
means what? They are coincident circles, you want to say?
Yes, yes,
Same center
yes,
and same radius. No, I'm saying, let's
yes.
say I know they are distinct circles. They don't have the same center and radius. I mean, radius is same, but center is not the same. Anybody else who has raised their hand?
No, sir. I was thinking, but same I realized that it was.
Okay, so this is the flaw. This is where gamma 3 and gamma 4 can lie, and they can be of any radius. I'll draw gamma 3 like this, and I'll draw gamma 4 like this. Then they satisfy all the conditions of the question. They are tangent to each other, they are tangent to gamma 1 and gamma 2. And it can be any radius, right? There is no special value over here. So yeah, very nice catch.
Just accept the two radii.
Sorry. I didn't get you. What are you saying?
Any positive or just accept the two radii of gamma 1 and gamma 2.
Right. Yeah, I mean, in theory, maybe, yeah, because we are saying they're distinct circles, so maybe those two values have to be stick. But yeah, otherwise, I should have maybe written in very explicitly that they are external tangent to gamma 1 and internal tangent to gamma 2 or something like that. Anyway, so an important point I want to mention, let's say in the exam, you found that this is the flaw. What do you do? This rarely happens, but many times maybe Olympiad questions can be wrong. So what do you do?
Solve the
Maybe
question using
mention it
obvious
in the
method and point out the flaw.
No, actually somebody was talking at the same time. Or no? What are you saying?
Maybe we should discuss, if it's an descriptive paper, maybe we should discuss both the cases. In the first case, we find R. Second case, we say that all are R.
Oh, and if it is not a descriptive problem, like what we have
Then
right
we should
now.
try to consider the case in which this is not like it is it is external to the circle.
Oh,
Then
yeah.
we should try the obvious one.
Yeah, okay. So yeah, that's what I just wanted to hear, that if you find the flaw, you have to understand that, I mean, this is a genuine mistake the examiner has done, and you have to solve the question like normal anyways. But of course, if it's a descriptive question, then you can explain this in more detail. Okay, so anyway, this point being as it is, assuming the obvious case, there is a symmetric like this. By the way, in reality, we have to also prove why this obvious case is the only possible diagram. Why is it not the case that the circles could be like this, maybe on one side, okay? Like, even in this case, that circles are tangent to each other and everything, but the radii are not equal, obviously. One circle is larger than the other circle. But we have never proved it formally, right? So maybe good exercise for you to see why this diagram can never have equal radii. But again, assuming that we know that for sure. Yeah, drawing tangent circle is always hard. Okay, so how do we approach this problem? Can anybody explain if you already solved it?
Yes, sir. Can I?
Yeah, go ahead.
Then we should join all the centers.
Okay.
Then we get two isosceles triangles.
Okay.
Then also to B.
Also to B. Okay. And let me give them some names. So O1, O3, O4.
No, sir. Sorry, sir. I think you should join AO3 and AO4.
Okay.
So we know AO3 in terms of R, AO4 in terms of R, O1, O3 in terms of R, O1, O4 in terms of R. So we calculate the O1 perpendicular and A perpendicular and subtract them to get O1A, which we know.
Okay. So if I want to put it in just one sentence, whenever two circles are tangent, what happens is the distance between their centers is equal to the sum of their area or the difference of their area, based on whether they are internally or externally tangent. Okay. So this is the fundamental thing that we have to reuse again and again. So if I have two circles which are externally tangent, then the distance between their centers will be r1 plus r2. Correct? And if they are internally tangent, it will be r1 minus r2, which is the larger minus smaller. Okay. So I just have to do that again and again for every pair of circle which is given tangent to me. So what I know is that this distance is 9, 9, r. And let me temporarily call this distance as h or maybe x. Okay. So the distance between the point of tangency and a, 80. So I see there are many Pythagorean right angle triangles which are possible here. So for example, look at this triangle. Okay. So if I apply Pythagoras theorem here, what do I get? So r square plus x square is equal to O3a square. But as what I just described, what can we write O3a as?
18 minus r.
18 minus r, right? So this is my first equation. And then another Pythagoras triangle which I can look at is O1 T O3. So this triangle. So here, what can I write the expression as? R square plus O1T. So O1T is x plus 9 is equal to O1 O3 square, which is r plus 9 square. Okay. So we have two unknowns and two equations, and you can solve it easily. In fact, it turns out to be a very nice example. I think r is equal to 8, x is equal to 6. Right? Yeah. This turns out to be the answer. Okay. So once you set up the right equations, it's not very hard to eliminate x and get the answer. Okay. Any doubts in this question? Okay. So I mean, I hope you realize that. I mean, this was the 5-mark question, but is there anything that is so difficult about this question? It just multiple applications of small things which you already know. So we all know Pythagoras theorem. Maybe you also know this diagram. So the fact that when you have tangent circles, the radii, sum of the radii and the difference of the radii. It's just that you have to apply these concepts in the actual configuration. Okay? So what you need to do for that is basically various properties that you know. Like I hope everybody knows what is in circle, X circle configuration, or the 9-point circle configuration. So all of these you have to treat like templates or stencil. You know what is a stencil, right? You keep it on a tracing paper and you can draw something below that. So in that way, you have to imagine that like a stencil or a template, and you have to stamp it on this diagram. That okay, I can see that configuration over here, and so I can apply those properties over here. Same thing which we did, for example, for the this question, for every question for that matter. So here I saw that there is a Pythagoras triangle happening, and I could immediately apply this property, which I knew, 1 over x square plus 1 over y square. So every question has this kind of set pieces which are just assembled together to give you the question that you are solving. Okay, so if you recognize those set pieces and you apply those properties, I think no question is hard then. Okay, so we are almost towards the end of our list. Question 2, 6, and 12.
Sir, Descartes theorem is like the figure is same, very same.
Descartes theorem, which theorem are you referring to?
Descartes, sir.
I don't know exactly. Can you explain?
Sir, it is an equation like which satisfies like there 4 radius are there.
Mm-hmm.
3 are
I think it's in a semicircle, right?
no sir, in a full circle.
Okay. Can you just tell me what is the full theorem?
Yes sir. Sir, similar figure like 3 circles are inside a big circle.
And they are all tangent
All
to each other.
touching. Yes.
I see. Okay.
And then
Okay.
that Descartes theorem provides an quadratic equation.
Okay. So the radii of the circles are related to each other in some way.
Yes. Yes sir.
Okay. So by the way, I think why are we calling Descartes theorem? I mean the mathematician is called Descartes, right?
Okay
Assuming
sir.
that this is the same person you are talking about. let me just Google it. Actually, I never heard of Descartes theorem in this way. Yeah. Oh, it is Descartes theorem.
Yes, sir.
But I think the correct pronunciation is Descartes. But anyway.
Okay, sir. Yes.
Interesting. Oh, I see. Yes, I remember this now. Yeah, interesting. I think we can we have to see how to prove this. Maybe the approach which I mentioned, like you do it 2 circles at a time, may take a lot of effort. Maybe inversion or some idea like that could be more useful. Okay, I'll keep this in mind. Maybe one of the future lectures I'll try to cover this.
Okay, sir.
Okay, so this was question 11. Question 2, 6, and 12. Okay, question 2. I think it was actually quite straightforward. I don't know why so few students got it. Or maybe did you make some calculation error or where did you get stuck?
Sir, I missed one case. That is why.
Okay. So when you try to list out all the values?
I factorized 2022 and then I list out.
Yes, sir.
Yes, sir.
Factorization.
Okay, I think most of you are trying to list out the values. So that is why maybe you got there. No, Anushka, you were saying something different.
No, sir, I said I factorized 2022 and then I got the list, like what all.
Okay.
So that.
Sir, actually, Prakash sir did this generalization in the fast track batch this year.
Okay. So then everybody knows what is the right approach, right? Then what happened? Maybe you forgot what was discussed in the class.
No, sir.
Yeah. So I mean the idea, just to recap, at least the solution which I have in mind is, if this is the factorization where these are all prime numbers and the numbers we are talking about m and n, so that will be 2 raised to something, a1, maybe b1, c1, and a2, b2, c2. So the pair a1, a2, b1, b2, c1, c2 should be such that because the LCM is this much, so no value can exceed 1, right? So like for example, take the pair a1, a2. What are the possibilities? 0, 1, 1, 0, and 1, 1, right? These are the only 3 possibilities for a1 and a2. And same for b1 and c1. So there are total 27 such possibilities. But in that one case where m and n turn out to be equal, where like 2022, 2022, this case I have to drop because I am given that n is less than n. So therefore I have only 26 possible values. But in that, because the question says m has to be less than n, so every symmetric pair has to be counted exactly once, right? So for example, if I have 2, 2022 and 2022, 2, out of these 2 pairs only one is valid, where the first number is smaller than the second number. So I have to do 26 upon 2 and the answer is 13. Okay, so this was the expected solution. I hope everybody is following what we are doing here. Okay. So yeah, I think in case you didn't get this problem, that highlights the importance of revision. That something that is already covered, but you did not revisit, that can hurt you in the exam. Okay, question 6. Interesting. You know, I've been reusing this question so many times. I think this is the 3rd time I've used this question. Every time I just make one small change. Because I conduct this entrance test every year, right? So last year also, if you get the paper from somewhere, the same question is there. Only one word is different. Instead of saying by at least one person, maybe I have written at most one person. Some I don't remember the detail, but everything else is same. Just by changing 2 words, I change the question and it's a fresh question. So let's see if you can also change just 2 words and come with a different question. So the best approach here is just to make the cases in terms of the distribution of the flavors. So there are 3 flavors and every flavor has to be chosen by somebody. So if there are, if I call the flavors as ABC, then what are the possible sort of ways of distributing that? So for example, there could be case 1 where same flavor is used by 3 people. Okay. So same flavor is used by 3 people. So basically it's like a 3-1-1 kind of distribution, right? So one flavor is chosen by 3 people, somebody else chooses the second flavor and somebody chooses the last flavor. And the case 2 where 2 flavors are used by 2 people. So it is like a 2-to-1 distribution. These are the only 2 possibilities. There is nothing else that can happen. So in the first case, like if the distribution is 3-1-1, then how do you count this? First you have to choose which of the 3 flavors is getting chosen thrice. So there are 3 ways to choose that. Let's say for example, flavor A is getting repeated thrice. Okay, so basically 3 people are going to get A, and then somebody is going to get B and somebody is going to get C. Now it's simply a matter of figuring out which person is going to choose which flavor. So here what you can do is first determine who is going to get A. So if I choose 3 ways to choose who are going to get A. And now the remaining 2 people, one of them has to pick B and one of them has to pick C. Okay. So in the case 1, the total answer is 3 into 5 choose 3 into 2. Okay. Similarly for case 2 where the distribution is 2-to-1. So first you have to pick which flavor is going to be the one. Like only one person is going to choose that flavor. So there are again 3 ways to choose that. So 3 ways to pick what is that solitary flavor, so to say. So let's say that solitary flavor is A. So only one person is going to pick A. Then 2 people are going to pick B and 2 people are going to pick C. And again the same thing that you figure out which 2 people are going to pick B. So if I choose 2 ways to allocate B to somebody. Now there are 3 people left. So out of those 3 people, some 2 people will choose C. And so the answer in this case is this. So the total answer turns out to be 60 and 90. So the answer is 150. Okay, so this was a quick rundown of the idea, but I hope you got the steps involved. So again, make intelligent cases. Make the cases so that each case can be tackled separately and it covers all the possibilities. Any alternate approach?
Yeah, I had done it method that first I took 3 like ABC, say people 1, 2, 3, they have taken ABC, so I found out how many ways that can be arranged, and then the remain 2 cakes, how can they be arranged, something like that.
Okay, but the problem there is, why should ABC be taken by the first 3 people? Maybe first 3 people want, all of them want A, and the other 2 people will take B and C. So this case is not getting counted, right? So your approach was because we want to make sure that every flavor gets picked by somebody. That is why you forced ABC to all pick 3 different flavors. But in reality, that may not be the case, right? But maybe just go back and think. Maybe so we found a flaw in your approach, but maybe there is some way to fix that. So give it some more thought. That if there is some other way to take care of this. Okay, so maybe there is some, might be slightly longer way to get the answer, but you may still get the answer. So give it another try. Okay, so this was question 6, and so I think we are down to the last 2 questions, question 12 and question 8, which nobody got. In a way, it's not that surprising because number theory is, I don't know if you have done any number theory. In fact, so from next lecture onwards, this is where we are going to start. Okay, we are going to start with number theory from the next lecture. So I think question 8 I might skip for today because there is some notation or some ideas which we are not introduced so far. So maybe once everybody knows that basic terminology, you can reattempt question 8. But question
What
12.
is the answer for question?
Question 8, the answer is 450. Okay, the answer is 450. Okay, question 12. How many people got that? Less than 10%. So maybe 3 or 4 students got this question.
So what is the answer for question 12?
The answer of question 12, I don't remember the answer. 252. By the way, I mean, do you see how I've written the PDF? So the first, all the questions are given, and at the end, I've given the answer key and the hints to all the questions. So I'm just giving an idea of how you can create your own, when you are going to design your own questions, do it in this way, okay? Have the question separate and have the answer and solution or hint separate. Okay, okay, so can somebody tell me what can be the starting point of this question?
Sir, can I try?
Yes, go ahead.
So matter.
Garu, are you saying something?
Yes, I was asking if I could explain how to do it.
Okay, go ahead.
Yes, so what I went ahead and did was I first drew an 8x8 grid.
Okay. Just give me 1 minute. I have the ability to use 8x8 grid, so let's do that. Okay. Okay, what do we do now?
Yes, sir. And then I assumed that my piece, which is the king, which is going to be moved, I assumed it at one of the corners.
Okay.
And if we observe that if it has to reach on any of the other corners, it will take at a minimum. It will take only a minimum of 7 steps.
Right. So basically, from this corner, any other corner is at a distance of 7. Correct?
Yes, sir. So
Okay,
because
go
even
ahead.
if we consider diagonal steps, and
Okay.
suppose I have to go to any other corner, means not anyone in the last row or column, it also takes a 7 steps because we can take a diagonal step.
Yeah, correct. So basically, this entire row and column will get a distance of 7 from this
Yes.
starting point. Okay, correct.
Okay. So for like this, we have 4 possible combinations where the piece could be at any of the 4 corners.
Okay.
And if the piece is at any of the last row but not at the corner, like means in the
Okay,
first
somewhere in
row.
between, like this, for example.
Yes, sir.
Okay, then what will happen?
Sir, then the 7 at the right will get cancelled out, but the
Right.
bottom 7 will remain.
Right. So in this case.
Yes, sir. And so for all possible pieces in the first row except for the corners, all possible values will be the rows in the bottom row. Yes.
Right. So how many such positions are there which are not at the corner?
So there are 24.
24, right? Because 6 on each side.
Yes, sir.
Okay. Okay, so I think the sum of this will be the answer, right?
Yes, sir. That comes out to be 252.
Yeah. Okay, did everybody follow what girl said?
Could you
That,
explain this again?
I mean, first thing which is important to mention is that the king, if it is anywhere in between the board, like not at the edge or the corner, then any square on the board is reachable in less than 7 moves, correct?
Yes, sir.
Like
Max
if you
6.
take,
Yes, sir.
right, from here any square is reachable in 6 moves. So therefore none of the middle square are going to matter. It is only the edge squares that have to be counted. And in that, the cases that he made, so first, because we want to look at a pair x comma y, so we are only going to make the cases on the x. So all the possible values of x, and for that each value, how many values of y are possible. So when x is at a corner, we see that y can be one of 15 possibilities. So that is how we got 4 into 15. And if x is in the middle of the edge somewhere, then y has exactly 8 possibilities. So that is how we got the answer to 52. Okay, does everybody understand this approach?
Yes, sir.
Okay. Okay, so as I said, question 8 I'm going to skip, but the remaining 14 questions we have covered. So as I said, after the lecture is over, go back, take a fresh look at the paper. I'll send this PDF to everybody, by the way, so you can get a chance to look at all the questions at a glance. And as I said, the task for you is try to create your own version of some question. See, be creative. Try to find some ideas of how you can make the question different or more harder or anything like that. And of course, you should be able to solve the harder question, not just that you make a harder question and then you give the solution as exercise to the reader. That is not very useful. Any other comments or thoughts about this paper?
So I had a question.
Yes, go ahead.
Sir, I wasn't able to solve the first question as well in the exam.
First question, okay. It's just a trick question actually. I mean, there is nothing in that question which is not doable. It's a 12-sided polygon, right? Let us draw a 12-sided polygon. Okay. So what is the smallest diagonal in this diagram? Let's say starting from vertex A.
I guess AK.
AC, right? AC or AK, either or.
Yeah, AC or AK.
And what is the largest diagonal?
Diameter.
Yes.
From A to the opposite side.
From A to the, so AG, correct?
Yes. Yeah, AG.
Okay. So now what I want you to look at is this polygon instead. If you just take every alternate vertex of your regular polygon, you get a regular hexagon. And what I'm asking is the ratio of AC and AN in that hexagon.
Yeah.
And if I connect everything to the center, do you see they're all equilateral triangles?
Yeah, right.
So I mean, this is a kind of standard property. I think everybody knows that.
Yes.
This is a very nice symmetric diagram. So yeah. So I mean, I wanted to ask this hexagon question, but then it would be too obvious, right? So this is what examiners do. They disguise the hexagon and they hide it inside a 12-1. That's what all this question is.
Yes, so the answer will be 2.
Answer is 2. Okay.
Yes, I got it.
So maybe you want to generalize this. Find for a regular 24-sided polygon, find the ratio of the length of the largest and the third smallest diagonal. That's a new question for you, but it's the same question. You see, it just looks like a different question, but it's really the same question. So yeah, I hope you get creative and submit lots of different ideas on this thing.
You were also sharing the answer key of this.
I'll share the answer key. So, and in fact, I mean, I've not written out the full solution of any question, but I've given 1 or 2 line hints. So from that you can figure it out.
Yes.
And in fact, I'll encourage you to do that for the questions which you are also designing, right? So you'll write the question on one page. You'll write the full solution on a separate page. But if possible, also write a 1 or 2 line hint also separately. Okay. So if you were to somebody comes to you and says, I'm not able to solve this question, can you give me a hint? What will you tell them? So just write that in 1 or 2 lines also, because that will also help to crystallize the strategy in your mind. That okay, what is the approach that you are suggesting to solve this question? Okay. So we are almost done. So we have 15 minutes left. Of course, there is not enough time to start a new topic, but I don't know if anybody already knows what I do in every lecture. I always end the lecture with a puzzle or a riddle or some mathematical game, something like that. And many times there is some illustrative value to that puzzle. It many times connects with some topic which you will do very recently in the next 1 year, 2 year, or maybe eventually if you go to some engineering discipline. So the range can be quite broad that way, but there is something useful in that. So what can we do this for them? Okay, how about this? And by the way, I mean, none of these are completely new puzzles. Many of them are there in literature, so you may already know the solution. In that case, just allow others to try it. So the puzzle goes something like this. There are 1,000 bottles of water. Okay. And one of them is poison. And you have to find out which is that poison bottle. What we are allowed to do is, actually there is a backstory behind this. Let me tell you the backstory. So there is a kingdom and there is a king, and the king is going to have a big party tomorrow. And these are the 1,000 bottles of water that they are going to use for that party. And then suddenly 24 hours before the party is going to start, some spy informs the king that one of the bottles is poisoned. So the king has exactly 24 hours to figure out which is that poison bottle. Thankfully, he has a large supply of prisoners who he can just feed the bottle and figure out which of them is the poison bottle. But the difficulty is this, that that poison takes 24 hours to take effect. Okay, so maybe right now he'll feed the bottle to the prisoner, and then only 24 hours later he'll come to know that whether the prisoner dies or not, and then which bottle is the poison one. And so the question is, how many prisoners do you require to find out what is the poison bottle? So, for example, we could have 1,000 prisoners, right? And by the way, important to say that even one drop is lethal. So you don't have to fill the entire bottle to that person. Even if you give one drop, that is enough to kill the person. So what you can do is very simple: line up 1,000 prisoners. First bottle, give one drop to prisoner 1. Second bottle, give one drop to prisoner 2, and etc. etc. So one of the 1,000 prisoners will die, and you figure out which is the poison bottle. But do you really require 1,000 prisoners, or can you be clever and do something better? Okay, is the setup clear?
Yes, sir.
Okay, so what can we do? And say the difficulty is they only have 24 hours. Suppose there is a lot of time available, then only one prisoner is enough, right? Because one prisoner will give one drop from the first bottle, you will wait 24 hours. If he does not die, then you try the second bottle, and so on. But that will take 1,000 days to execute, but you don't have 1,000 days.
I have sent most of my thoughts in chat.
Yes, that is fair. So Arnav suggestion is we only require 999 prisoners, because what I said, give first bottle to prisoner 1, second bottle to prisoner 2, 999 bottle to prisoner 999. If nobody dies, then the 1,000 bottle is the culprit, correct? So yes, we have reduced the number of prisoners by 1. Can we do better? And by the way, there is no rush to come to the answer, because we never complete the puzzle in the same lecture. So we'll discuss the solution to this the next time, but some food for thought. And I mean, typically what happens is, not only we discuss the puzzle, but we see the broader implication of this in terms of mathematical theory. That what is the consequence of this puzzle? Where do you encounter this in real life? Even if you are not a king with a kingdom of 1,000 prisoners, you still require this theory somewhere else. So you will discover what are the mathematical roots behind this topic, and yeah, a lot of fun discussion will happen from there. But I think if there are no other comments, we can end the lecture early today. So as I said, do post your questions and your new solutions on the WhatsApp. Okay. Okay, that's all. Thank you, everybody. Bye.
Thank you, sir.
Thank you. So
Thank
Bye,
you, sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you, sir. Bye, sir.
Bye.